Welcome to another episode of Beyond GIS. In this episode, we dive a little deeper. We have a look under the hood at what we're actually doing here at Orbica and some of our struggles and pains to go on the journey we're going on to building out a next generation geospatial platform. Along on the journey and take number 2 is Santosh, our platform lead. Let's get stuck in. So, Santosh, when you sort of reflect on what we're doing and what we're looking to solve, I guess in your words, give me a bit of a view. You know, you've been with Orbica since day one. Give me a view on how, in your way, we've landed where we've landed and the journey we've gone on as Orbica, and where we're now going to. How do we empower many people to sort of get access to the tooling and the knowledge we've had over the years?
Yeah, thanks, Kurt, for inviting me again to the podcast. Orbica's journey, since we started, we've been developing bespoke kind of applications, solutions, data analytics products and data products for various customers. And what we've kind of noticed is there are some similar patterns that we've identified, some similar challenges. So even though the content of the project or the content of the work could be different, but the challenges were pretty similar. So some of these challenges were like, for example, data management. You know, how do you manage large geospatial data sets? How do you provide kind of access control to various data sets to different consumers of data? How do you analyze large data sets? How do you combine spatial and AI together to create more kind of insights out of the data? So over the years, we've developed these projects and delivered projects where we've delivered kind of one-off point solutions to solve these problems, but our way of solving those problems have been very similar. So that's where the idea or the inception of this platform concept came about being, is why not allow other people and other users to be able to take advantage of these patterns and be able to deliver their own solutions themselves. And so the idea of the platform is to kind of give people the power and the access to knowledge that they can then implement their own solutions, and then we can create a kind of a standard for creating geospatial applications and products. So that's where the idea of the platform started off for us.
So, I mean, if you look back at a lot of the work, and obviously particularly the persona type user research work we've been doing over the last 6 months, what are some of the biggest challenges, the grunty ones? So let's think data, I guess, scale of data, formats of data, interoperability.
Yeah.
I mean, what does that mean? What does that look like? What were some of the challenges?
So some of the main personas that we've been kind of researching and working with are kind of environmental scientists, data scientists, and developers. So all of these 3 personas kind of dabble in GIS or geospatial, but they're not geospatial or GIS experts, right? So for example, a data scientist might be dealing with a large set of aerial imagery or satellite imagery or sensor data or IoT data, but might not necessarily know how to spatially manipulate it, for example. Or an environmental scientist who might be really interested in, let's say, river heights or looking at flooding or things like that. But again, they have their own set of tools and methods that they use, but they might not consider the spatial aspect of it. Same thing with a developer. A developer might need to put a map or make some fancy charts or apps that uses maps, but because they don't have access to the geospatial knowledge, they haven't been able to kind of tap into the full potential of geospatial. So those are the main personas that we've researched. And what we have kind of found is, yes, there is a deep interest. In the research, we also found that data scientists are aware of this concept of geospatial, but are not really engaged or not really know how to use it. So that's what we've taken into our platform and seeing how we can empower these kind of personas initially to start leveraging the use of geospatial. And as the product or as the platform matures, we can start bringing in more personas and kind of understand how can we democratize the access of these tools to other personas as well. Not only is it relevant to data scientists and environmental scientists, but also things like IT operations, or DevOps, for example, when you're delivering or when you're optimizing or deploying geospatial applications, there's a lot of security and performance considerations that IT ops and DevOps people need to be aware of. So that's also part of the challenge, is how do we kind of educate and empower those personas as well to leverage the use of geospatial.
All right, so if we take a tangible example, projection systems and just the whole construct around projections is very normal to us in GIS, geospatial land, but for pretty much everyone else, it's obscure. They don't understand it, right? And actually, should they? In this day and age, this idea of being able to have a workspace, however it's defined, that this is the projection system and it's abstracted away and everything's maintained using automation within a certain projection system, surely that's a great step to democratization or removal of some of this jargon.
Yeah. So it's a good question. It's the level of knowledge. So like, for example, if you're doing, PhD or research in geospatial, then yes, it's absolutely necessary for you to understand how projections work and how do we create newer, more useful projection systems and coordinate systems. But if you're just a developer or if you're a data scientist who is trying to get insights out of the data, you just need to know that the concept of coordinate systems exist. You don't need to know how they're developed or how they're working. You just need confidence in your data sets that they're going to work and they're going to show up in the right place on Earth when you bring them up on a map. Right? So that's part of the challenge. That's what the platform is trying to do, is trying to simplify and abstract that information based on the persona, right? So if you want to dig deeper and you want to get into the deeper aspects of coordinate systems, then you can. There are kind of open source libraries and tools available that you can go and contribute to and create more coordinate systems and models. At the same time, if you're just a data scientist or an environmental scientist and want to make sure that all your data sets show up in the right place, then the platform will give you the capability that you can just enable that feature that makes sure that all my data sets show up in the same place and everything in the back is managed and maintained for you and taken care of. So you could have, and that's the segregation of knowledge as well. So depending on your team, depending on the specialists within your team, you can have different controls. So for example, if you're a pretty kind of a deep geospatial consumer, then you can go and dig deeper into the coordinate systems. But if you're not, then you just need the ability and the confidence that your data is correct and it's going to show up in the right place. So it's about managing that level of abstraction of that knowledge and being able to deliver that knowledge to the right persona at the right time when they are trying to solve that problem. So for example, if I'm an environmental scientist and I'm trying to solve a flooding management problem, I don't care what coordinate system it is in. I just need to make sure that all my data sets are in the same coordinate system or in a relevant coordinate system. That's all I need to know. I don't need to know the inner workings of how a coordinate system works, right? So with the platform, when you import those data sets, we can give you ability and capability where you can just check a box and all your data sets are transformed and stored and projected on the fly and stored in the database in the same coordinate system, so that as an end user, you don't have to worry about reprojecting it every time that you bring in, for example. So that's one way how we can start solving or start providing value to these consumers or the users who are not traditionally geospatial by leveraging the geospatial technology.
So again, it comes back to that democratization aspect, right?
Yeah.
It's the complexities there, the knowledge is there if you need to dive in and you want to dive in.
Yeah.
But actually for most, abstraction's better.
Yeah.
Let's get on with the work that actually matters and remove barriers.
Yeah.
So on that note, so if we go, and again, learnings and challenges over the years, both for Orbica, our customers and the industry at large, is productionization. And you touched on it slightly earlier, but we see so many things happen. And Orbica's been involved in innovation projects with customers, of course.
Yeah.
How do you get them into production at scale, cost effectively, in an automated way that's maintained really well and doesn't need, a bunch of people trying to keep servers running?
Yeah.
What's your view to what we're doing there, our sort of vision to that, and sort of the value that can now bring to actual ROI being returned from geospatial data tools investments?
Okay. Yep. So there are kind of two approaches here. So obviously, traditionally, for deploying geospatial products or applications into production, we've had to use kind of traditional big kind of proprietary software to be able to do that, because they provide you all the cushion around it so you can provide with confidence. But now, as open source tools have matured and cloud technology has matured quite a bit, that we are able to provide the same level of kind of performance, security, and confidence with open source tools as well. And usually most development of geospatial products usually have 3 or 4 aspects to it. So one is obviously the data aspect, on the data management aspect of it. Geospatial data, as we all know, is large. And as the world is growing, there's more data coming in. That means that the size of the data is just going to keep growing. So that's your first roadblock to push to production is data storage and data management. There are plenty of cloud native tools available to just manage data, but there isn't one that manages geospatial data for that matter. But there are open source tools libraries out there that you can combine with traditional databases and data stores to provide geospatial capabilities. So that's one aspect, is how do we manage data in a scalable and a performant way. So now there are cloud native tools available and open source geospatial tools available to combine them and provide them in cloud at scale at a performant, secure basis. The next step is, once you have that data, is the processing and the analytics and APIs out of that data set. That again traditionally required some software that allows you to manipulate spatial data. Again, now the open source tools are pretty mature, and because there are tools available for every single function in geospatial, we can use the concept of cloud technology and microservices to provide these custom services that manipulate spatial data independently and provide them at scale. So then now specialists like data scientists or environmental scientists can leverage open source geospatial tool, combine them with their data science models, combine it with their environmental science models, and leverage the use of geospatial and provide them as services to the next layer, which is then coming down to the presentation layer, which is once you've got the data, you've done some analysis and some processing, and now you want to be able to present them so that decisions can be made. Now, in the presentation layer as well, traditionally there's been a lot of proprietary software that allows you to do that. But again, now with advent of a lot of charting tools, D3, open source libraries like Leaflet and Mapbox and all of these guys, there's tons of kind of open source mapping libraries available that allows you to present the data on a map. So with that, now developers can now just leverage that and just use that capability. As a developer, you don't need to know how it was managed, how it is being processed, how it's being analyzed. All I need to know is how do I show these particular data sets on a map and how do I control the visualization of it. So you can focus in that space. Whereas a scientist or an environmental scientist or an analyst can just focus on the middle layer of processing and analyzing data. And then your database admins and your data administrators can focus on that first layer of data management using their own tools with geospatial available in each one of these kind of different layers.
It's really interesting, right? I mean, it's that multifunctional, cross-functional collaboration.
Yeah.
Right. So you're giving the right tools to the right people depending on the sort of data chain or the aspect of the data chain you're at.
Yeah.
Speak a little bit about what we're doing with the platform and some of the early thinking around that sort of front-end developer app persona.
Yeah.
I think it's really interesting, right? Because in our world, there's a trillion templates out there.
Yeah.
But they're super generic. And we know as soon as you start putting apps, data, visualizations in front of customers, the actual stakeholders all have a different view to what you're trying to get across to them, right? The story you're presenting.
Yeah.
So what are we thinking in terms of just bringing the right tools, frameworks, thinking, knowledge to that persona?
Yeah.
To just let them use the tools they love to create what they always do, but time to speed to value.
Yeah. Instead
of here's a generic template, everyone spends hundreds of thousands modifying a template. Well, actually, use the best tools to start with.
Yeah.
What's your view? What are we thinking?
So in a standard kind of application development process, you always have this piece of kind of UX UI that happens, which is very traditional, which is very kind of standard practice in normal any app development kind of projects. But it's not necessarily the case, I find, in geospatial because of the restrictions that we talked about, how most of our apps are kind of templated. There are only because, if you notice, most of our applications are map centric, not geospatial centric. I'm saying map centric because everything is focused on a map. Whereas when I say geospatial centric, it's about using the tools of geospatial underneath to present the right information at the right level. So if you are an app developer, then as you go through the UI UX process, you can go as deep as you want because now there are spatial tools available to support that particular approach. Earlier, probably maybe 5-10 years ago, there were the geospatial tools were not as mature or conducive enough for that particular approach because you're kind of locked into this templated idea. But now that the tools are available for a normal developer, he can just continue doing his normal process of app development and go to the UI UX and kind of leverage geospatial where it needs to be, where it's needed. So right now, we can develop any experience for a user, just like we can develop any app for a customer. And we can use geospatial wherever we want, not just, oh, we need to have a map page, or we need to have a map-centric kind of view and kind of jam other insights on a map, because it might not be the best way to visualize a particular piece of information. So if you go through a proper UI UX process and you understand that you only need a small map in the bottom corner to show something, and then others can just be other charts, we can do that now. We have the tools and capabilities to do that. But previously, it was really hard to do because all of the applications were more map-centric and more spatial-centric. So as developers, if you want more real estate on your screen, or so you can do other things, it was kind of hard. If you want to do transitions from maps and things, were kind of difficult. But now there are tools available to kind of make that happen. So now the developers have more freedom and have more creative freedom to be able to develop more richer user experiences by leveraging the more modern kind of spatial tools and libraries available out there.
I think it's actually a really good point, that map-centric versus geospatial-centric.
Yeah.
I mean, so many of our most successful solutions were built over the years often have a minimized, sometimes invisible mapping component.
Yeah.
Because actually it's the power of geospatial under the hood to draw out insights, build relationships between the data. That's where the power is at, right?
Yeah.
And a map is just another medium of data presentation when you really think about it, right? And so back to basics, where's the value? What are we truly trying to do?
Yeah.
And who is the audience, and how would they, best utilize the information, the knowledge we're trying to give to them?
That's right.
Really good point. Yeah. So, I mean, on that note, if we step back one and we think about the sort of analytics capability and what we're thinking there, again, you see so many workflows inside business where such and such a team is using Excel, it spins up somewhere, sits in a cloud, gets pulled back down to QGIS, ArcMap, whatever, spins back up over to another tool. And it's all because they all speak different languages, use different proprietary tools or systems, and the data chain is just a mess the whole way through, right?
Yeah.
So what are we thinking around our sort of common language from a scripting, analytics perspective that will empower as many people as possible from different disciplines?
Yeah. So again, I'll start with the kind of the traditional approach. As I come from the same approach, being a GIS professional, we don't come from a very strong development or coding or that kind of a background. So a lot of our tools are, and GIS and Geospatial is a very visual kind of a discipline. And so we come from a very visual tools. So all of our tools are very kind of drag and drop, click button, click ops kind of tools. And because of that restriction, we have been kind of restricted to do some click ops and then pass that on to the next person who then does some other click ops and then produces a map at the end. But now, with advent of with more improved versions or more advancements in languages like Python, for example, you can do Python is probably the language that the data scientists probably live in. And now it's also becoming the language for geospatial as well. There's almost a library in Python to do anything that you want to do in geospatial, and combine it with your already existing knowledge of Python for data science or environmental science or any other modeling work that you're doing. We are now able to leverage at that level, and also the new professionals coming out will also have a bit of a background in coding and a bit of a background in development. So they're able to now access the data store or the data at its richest form, at its lowest level. So even though if it's like 4 terabytes or 5 terabytes, it can stay up in the cloud. We can move our models or our algorithms to the cloud near the data set, and we're able to run them at the source of the data, which makes it more performant, makes it more scalable. Because previously we've always had to pull the data down and then write our models and then run them locally. And that's where I think the bottleneck comes for productionizing things as well. If I've just pulled down 400 gigs of data and I've got this awesome model that runs very well on my desktop machine, how do I push that to the cloud? First of all, I've got a problem for pushing 400 gigs of data to the cloud. Then I've got the problem of where do I run my models? I don't have a GUI on the cloud to run my models. I don't have a authentication, security, permission, so that only I can run it, no other people can run it. So all of these create bottlenecks and create kind of I don't know, it's a turn off for you to push to production, or it's a kind of a barrier for you to push to production, because you got to make sure that all of these conditions are met. But now that we have cloud technologies and almost all of the data is now sitting in the cloud, and most of us are pulling data from the cloud down to our desktop machines to run the models, it's a switch in paradigm, or it's a switch in thinking of why not we move the code, which is a lot smaller piece of data, to the cloud and run it at cloud, at scale, on demand, at request. So that makes it a lot more usable, it makes it a lot more accessible, because now I can access that model and the data anywhere in the planet. I don't have to be sitting on my desktop machine to be able to access it. I can use my phone to run a particular model on the cloud, because it's not using my phone's CPU or RAM, it's using the cloud. I can scale it up and down as I need. So these kind of flexibilities are not available for you at the desktop level. And so that's where I see it going, and that's where I think the shift is from the whole ClickOps way of doing modeling and analytics to more kind of code-based and scalable way of performing. And that's where I see, that's what we found the world is moving in research. Even when we interview our kind of personas, agree that our personas are data scientists and environmental scientists, but we've also kind of interviewed some of our customers. And they're also pretty, now they're also very technically savvy, code savvy. They're happy to manage and maintain code. Now we've got tons of tools out there like Git and other things to manage versioning on code, manage permissions on code. So so that's where the rest of the world in analytics and modeling is going. Why not geospatial as well?
Yeah, cool. So if we're riffing off that a bit, I mean, the bit that sort of speaks to me, moving the algorithms, the code itself to the cloud, sitting that next to the compute, next to the data, all of a sudden it's 100% transferable anywhere in the world, right? From a functional perspective. Surely that's going to help enhance collaboration and remove that inertia of moving the 400 gigabytes from here to here to here to someone else's computer. What's your view there? And in particular, dive in a little bit to some of our thinking around, Git, I guess, but for the analytical code, not just apps where it's sort of matured out. What's your view there? What are we thinking?
Yeah, so, Git is a very kind of popular technology that almost everybody now uses as a standard to kind of version control and source control your code. So that allows for collaborators from across the world, anywhere, any scientist, any developer can jump in and contribute to a piece of code. Now with the cloud, with the addition of cloud technology, you can now push that code to the cloud and run it. So I can run a piece of code independently, see what my results are in my instance, and somebody else across the world can run the same piece of code in his or her instance and see what the results are. And then based on the results, they can contribute back, they can collaborate at the Git level, provide comments, provide feedback, or create some other communication channel like Slack or something and talk about it there. But they can still work on the same code base, which allows for a much higher rate of collaboration rather than me just writing some scripts in my machine and then sending that piece of code to somebody else. So that's one advantage of Git, obviously, that you can cross collaborate there. The second advantage of combining Git and cloud is if I have a piece of code that I've run in my instance and it's providing me the right results, I can just, with the modern ways of managing authentication and authorization, I can open up that instance to my co-collaborator or my collaborator, I guess, and then he or she can open up the same instance and see what I have actually built or developed. Prior to this, the only way to do that is for me to somehow package that whole thing up, send it to somebody in a zip file or a disk or a CD or even an email or Dropbox or something, and hopefully all the configuration and everything is correct, and the other person can open it up and hopefully it works. You can just hope that it works. And most of the time it doesn't work. There's probably always some back and forth going, oh, can I change this parameter or that parameter? Whereas here, I can just run my model or run my script or run my analysis and just share that whole piece of asset to my collaborator, who can then jump in and investigate what I have done. Now that is very powerful when you're talking about especially advancing science, advancing kind of analytics. You need that second pair of eyes to go through your piece of your work. So yeah, so that's where I think cloud technology and technologies like Git and the more modern ways of authentication and authorization are helping drive these kind of collaboration aspects forward.
I mean, I think it's so much of the inertia too, if we think about pushing something to production, is geospatial guys, data scientists. I mean, we're the classic hackers. Every new thing we'll have a play with, right? We'll have a look at.
Yeah.
But actually trying to control the environment somewhat
Yeah.
is going to allow for that code that we're testing here to be able to push to production really easily, right? Because
Yeah.
the variables, the parameters, the version control of the different libraries is all being handled
Yeah.
and orchestrated by the platform.
Yeah.
I don't know, speak to those challenges a little bit because we talk a lot about it's so hard often to get things into production after amazing work's been done and like the algorithms, the modeling, the data work, right?
Yeah. Yeah. So traditionally the challenge has been for especially IT ops and DevOps, the challenge has been they don't come from a geospatial world, so they don't understand the geospatial tooling that's been there, and they probably have to upskill themselves in how do I push these very either proprietary systems or closed systems into my deployment pattern. So that's one challenge. But now with the open source technology and cloud, the DevOps team or the DevOps specialist can just focus on his or her specialty, which is using the tools that they need to push stuff to production. So all they need to understand is Git. What's inside of Git is completely at the hands of the analyst or the scientist who are developing those models. The DevOps person doesn't need to understand what's in the Git as long as he knows that he can push this particular repository into this particular instance. Yeah. That's all he or she needs to be aware of, whereas the analyst can focus on the actual content of the code itself. So that itself is opening up the collaboration between IT or DevOps and analytics. Previously, that was very hard and challenging because usually from geospatial systems, it's really hard to export out or create models that can run independently of the geospatial system. But right now, you can develop pieces of code or pieces of tools that will just run by itself. You don't need the whole ecosystem of geospatial software or systems to be able to run one piece of, let's say, I just want to make a service that does a buffer, that takes a particular lat long or it takes a particular location, and all I want in return is just a buffer of 5 kilometers. If that's all I want, then right now, with Git and with Python, I can just write a particular service that'll just do that. They'll just accept a lat long and provide me a 5 kilometer buffer. Whereas previously, I would have to install a geospatial server, I need a geospatial database, I need a geospatial kind of system, geospatial authentication management in order to be able to just provide that one service that I want to create a buffer. Whereas now, I can just create a small service that runs independently of everything else that can be used by anybody and deploy it. Furthermore, for example, for an application developer, when they're developing kind of spatial visualizations and spatial apps, again, like I said earlier, they don't have to worry about the analytics that goes in the back of it. All they need to do is hit an endpoint to get the result, right? And now, if I can write an independent service that does the buffer, which is now running as an API in the cloud, then the developer, all he needs access to is that API, and now he can hit that and get the buffer that he needs, and he can display it in the front end. So now that's possible only with 2 or 3 libraries. You don't need a whole ecosystem or a whole setup of a massive geospatial software. You can just do it with 2 or 3 different functions and tools.
It's amazing, right? So this is where cloud native gets really interesting to me.
Yeah.
Because all of a sudden you've got, it's distributed. Each of these services can scale independently based on demand or parameters or whatever the platform administrator or the analyst wants to see from that, or developer. But the robustness that can come from that, right? Yeah. So traditionally, so much is still that application tier. We have application server. It's quite monolithic.
Yeah.
If it goes down, and everything goes down.
Yeah.
Right. So that approach here, that you might have one service inside that app calling an API that may die. Okay, that'll figure itself out, self-heal, sort itself out, but it hasn't broken the entire app, the entire solution.
Yeah.
That bit really excites me.
Yeah.
Because so often in the past we're managing this monolithic thing, and it's scary.
Yeah.
And just think in the world right now we're living in with emergency management having to happen everywhere, the whole thing going down is scary.
Yeah.
What does that look like? How are you thinking about some of those elements from a service level at a sort of project definition, or maybe explain some of our thinking around how we're going to break up workloads between sort of workspaces, projects, loosely coupled services, service catalog type approach?
Yeah. So I think this is where kind of we are working towards how do we expose or how do we leverage or use the microservices technology or microservices architecture concepts to geospatial. And so the idea is within the platform, you'll be able to, every organization will be able to create multiple workspaces, which allows them to create maybe more domain specific buckets of work. So you could have a workspace that's for hydrology, you could have a workspace that's for, I don't know, I'm just going to throw it out there, finance maybe, or you could have a workspace that could be for marketing. You could have different workspaces, and within those workspaces, you could have various projects. And all of these, so each project then can have multiple data sets, analytics, apps, services running underneath a particular project. So for example, if you're in the hydrology workspace, you might have a stage height or a water height or a river monitoring project, which can contain multiple services, such as you might need a database, you might need a few analytical APIs, you might need some analytical modeling, some models that might be, but it'll all be contained within the project. And then that particular project can then be shared across multiple users or multiple teams if you want. But that project is independent, right? So for example, if one of your model breaks, right, that doesn't mean the other project sitting in finance or marketing is going to break as well, because those are completely segregated, because that's the idea of microservices. You can decompose each of the functionality into each independent functions, and those functions run independently. So when a function breaks, only that function is broken, not your entire solution, like you said earlier. So this allows us the capability to provide even permissions and authentication and access at a functional level. And the vision of the platform is to provide that level of governance to our customers, to our end users, so they can provide that governance at the functional level. So an organization can say, we have a buffer API here, and this buffer API can be used by the entire organization. And they can open that up, and they can scale that service up and down based on the needs and based on the requirements. And then it's available for everybody to use. And then, or they can say, nope, I want to decompose that. I want to create a buffer function for each project so I can have a bit more redundancy. So they can just replicate that process across multiple projects and provide independent function or independent authentication authorization to those functions. So this allows us to reuse. So for example, if a customer or if a user has built a function and they want to reuse it in multiple projects, they can easily just, it's as simple as copying and pasting that same function into multiple projects. Then it's available for everybody to use. So that's one reusability aspect there. The other aspect is the decomposition aspect, is where I can just decompose just the function I need and just release that as a feature for my organization. As opposed to if I need to do a buffer, but I need to update all of my server things, it creates a lot more headache and a lot more overhead, which we're trying to reduce. So the idea is, how do we provide ease of use for users and for end customers to use function as a service, right? That's where the world is going. That's where more of the more modern platforms and applications are coming up. We're just trying to implement that in the geospatial world.
Oh, there's so many angles to this. I mean, part of it is the other bit, all to do with democratizing geospatial, getting it in the hands of more people, is that ability to scale things up and down, right? And not all things need to be scaled up and down in the same way.
Yeah.
So, hey, this particular project over here, maybe it's a big engineering company that's delivering a workload for a customer. Oh man, all of a sudden, that app is just getting horrendous amounts of hits, right? That thing can scale independently, fall over independently without breaking core BAU functions over here.
Yeah.
But I think that's a bit that's of real interest to me, because it also allows that cost control element to happen. So instead of paying for all the functions in every project and the overhead of managing all of that and its impact on resilience, it also allows that transparency of cost to serve, and really value to be better realized and propagated throughout an organization.
Yeah.
So maybe at a high level, speak to some of the work we're doing to be able to allow a customer to be able to look at and understand the cost around, I guess, projects and the associated projects, services, and how they can roll up into workspace and then roll up into organization.
Yeah. So again, from our user research, customer research, what we've found is most organizations are doing their budgets based on projects, right? So usually when you procure a project or when you start a project, you have kind of a rough idea. Hopefully you should have a much better idea, but you usually have an idea of what the budget of the project is going to be. And usually there is a IT spend or an IT budget within that particular project. So what we are kind of allowing us to do in the platform is each project can have its own independent, I guess, a cost model or a spend value, right? So you can say, I want to allocate X amount of dollars for this project, which means that they can set those limits within the project. So if a particular project has hit that limit and now it's getting hit more, and then the app or the project is not scaling because you've set that limit, that project will probably crash because it's hit that limit. But you can just go in and increase the limit if you deem it worthy to increase. Otherwise, I mean, most organizations have to go through some kind of a business case to get more spend, but that's a more business process problem. But from our technical side, we've kind of solved the problem. We're kind of working on the problem of how we can allow users to control cost almost at a service level, and then we can aggregate that up to a project level, or maybe even a workspace, or maybe even at an organization level. So the idea is you can go in and you can say, you can actually go in and monitor and say, this buffer API that I talked about earlier is getting smashed and is getting hit a lot. So maybe we just need to scale that bit. Maybe I don't need to scale the whole project. Not all the APIs are being hit. It's only that one that's being hit a lot. So maybe I just need to scale that one up. And so it allows you to kind of micromanage almost your functions and your services, which in this case is a good thing because you can accurately control cost and spend, and you're not just, in traditional monolithic architectures, you'll have to bump up or you'll have to increase the size of the entire
stack.
The whole machine. You might have to go from 2 CPUs to 4 CPUs, from 15 GB RAM to 18 GB RAM or 20 GB RAM for the whole machine, which means that your overall cost goes up quite a bit. But here you can just say, just this particular service requires another 1 gig. So I don't have to go up an entire 5 or 10 gigs. All I have to do is increase 1 gig on this one service, and that'll meet my requirement, and it won't, break my wallet.
That transparency and visibility. I mean, that's a paradigm shift, right? If you think about yourself as a CIO, you've got this geospatial stack over here. It serves all sorts of parts of the business. But to attempt to break that down and understand what value is being added to where across the business, very difficult, right? So, I mean, amazing. And it also allows you to manage both OPEX and CAPEX, right? And all sorts of ongoing things and projects as well.
Yeah.
What that visibility, that cloud consumptive thing, I think is really fascinating, right? And moving away from a user-driven sort of license model to a organizational subscription model. I mean, that's got to be a paradigm shift, both in terms of the technology, but actually just allowing the propagation to happen. I mean, how often have we come up against, we don't have the budget for this, or the total cost of ownership is too high because it's hidden, it's so complex.
Yeah.
You got the software licensing, the infrastructure to run it on, all the migration and upgrade cycles and consultants that often have to come in to go from version X to version Y, and then the associated time that's has a cost across all that.
Yeah.
I mean, I don't know. What's an interesting way to be able to show that total cost of ownership to truly compare it to the cloud? You have any thoughts there?
So, I mean, like traditional softwares or kind of classic softwares, because there's usually a software cost, then there is, like you said, the infrastructure cost. So those two are probably pretty transparent. People usually know what they're buying when they get those two things. But it's the maintenance and the support and the ongoing cost of ownership of that particular stack is the one that's not very transparent, because it's hard to measure, first of all, and on top of that, it is really hard to capture, because geospatial in an organization is used by so many variety of teams, parts of the business that you might be engaging with different geospatial entities at different times for different projects. You might have a centralized geospatial stack, but the procurement of the different upgrades or services that you need on geospatial might be hidden at a project level, and then there is no way to report on that. But now with the idea of the cloud native concept, if you have one centralized cloud native platform where the cost and the services and the hardware and the software is all sitting in one place, and everybody can log in and work on one platform, no matter if it's if it's the customer, if it's the user, or if it's the consultants, or if it's the services that they're engaging, they can just give them access to the platform, and all the activities that can now be monitored. And once they can be monitored, they can be logged, and if they can be logged, they can be visualized, and they can give you a much better representation of the cost of ownership, because you can actually see how much of the platform is actually being used and by who and what they're using it for, right? So that gives you a much clearer picture of what's actually going on in your entire geospatial ecosystem.
I mean, it actually reminds me of a conversation not too long ago with a big environmental organization, and they've got a big ELA. And we actually did the calculations. It was $75,000 a year, roughly, of cost to serve geospatial software to the geospatial, the GIS power users.
Yeah.
Like, it's phenomenal when you start breaking this stuff down. So again, I think that transparency with this inherently linked to value is really important.
So it's the other aspect of the cost transparency is one of the biggest challenges has been in the geospatial world is migrations and maintenance and support, because as software gets old, as libraries get old, they need to be upgraded and they need to be managed and maintained. If they are in regular traditional tins that are sitting on some computer, then you would need people to go in and manually upgrade those systems to the newer versions. The advantage of cloud is you don't have to worry about it. Right? It just happens automatically in the back. You don't even see that it's happening, and you get the benefits of the latest features. I mean, a simple example can be, I don't know, 10, 15 years, or maybe 5, 10 years ago, we always bought the Microsoft Office CD. So you bought the Office 08 CD, then you bought the Office 2010 CD, then you bought the 2015 CD. But out of 2015, it's all cloud. There is no CDs to buy, right? You just log on to excel.com and you got Excel. And you don't have to worry about upgrading Excel on your local machine. You don't have to worry about upgrading Word on your local machine. It just happens behind the scenes, and you get the benefits of the latest features. That is the kind of thinking we're trying to bring to geospatial, is the ability for somebody to just log in and start leveraging and start using geospatial without having to worry about the management and the maintenance of the software behind it.
I mean, the other element I was thinking about, and talking to a bunch of councils recently, actually in Australia, is, they're contracting folks out to do some work on, the roads. And everyone's got disparate systems everywhere, right? So they're sitting on some internal system. It's really difficult for them to provide access to these guys to get the sorts of access to the geospatial system. If they want, they need to federate their own system. They have to buy licenses. Like, it gets out of control really fast. What happens? The contractors store data over here in their own systems, but actually it's data about the digital twin of the assets for the council. But that knowledge doesn't end up back in the core data repositories because of all these reasons. And so much value is left off the table. Forward that 10 years and something happens. Oh man, I wish we had the blueprint for where those assets were under the ground. It's inaccessible.
Yep.
And so that multiplies itself everywhere. So that open accessibility and some of the thinking you're doing around authentication and permissioning is going to be key, right, to unlocking some of this value.
Yeah. So in that example there, for example, that council can just invite the contractor into their platform, and the contractor can work independently on all the projects or whatever that they're working on, the road assets and things like that. And they can continue to use their own specialized tools for surveying or for asset management or any of those things. But once they have done that piece of work, the platform can provide tools for them to just ingest the data back into the platform and store them and provide them in a standardized format. So that's the one thing that we are pretty passionate about, is about the openness and the interoperability and standards for data sets and processes and models and applications. because that is something that is seriously a wild west in the geospatial world. We all know the importance of metadata, but we never manage them properly. We all know the importance of data standards and interoperability, but again, we all work in very kind of siloed data formats. So one of the benefits or one of the features of the platform is we are completely open. We are using the OGC compliant standards, which are the open standards that have been set, and almost any software out there can consume and integrate with open standards. So we are allowing, that's what we are making OGC, and we're making the kind of interoperability our first class citizen for the platform, so that everything is open and interoperable, and you can wrap permissions around it, because that's the key. It's not, the format shouldn't be closed. The format should be open, but the access should be controlled based on permissions and legalities and other things.
Amazing.
But there's no reason to close the format itself.
So, with all this in mind, that use case we just talked to, the enablement of that barrier right now for the council to own the data that represents their assets, i.e. the digital twin, in their own system, is imminently achievable. And we're looking to solve that. Because it blows my mind that so much information and money goes into obviously maintaining our infrastructure, yet the data, which is the digital representation of it, can be the Wild West. Right? And so I think that's really interesting, because the right tools are going to allow council, in this case, to contractually write in to the contractors, this is where the source of truth data lands, this is where it must be, and we own it, we control it as council. Awesome.
And as the platform matures, we can start, integrating and building plugins and to consume data sets from other closed formats, and then still store them as needed, and then provide them as open kind of formats for other users to consume.
Look, there's so many more ways we could look at this, Santosh, and there's a lot going on with the vision of the platform. In your words, I've sort of touched on this concept of foundational customers, partners, and we have a few on the go, and we're talking to a number. What's your view to that and the sorts of partners we'd like in the early days that are really going to help us co-create and challenge us on our thinking, to be honest, so we create the best thing we can create? What in your world would you look for the types of partners, customers?
Well, what we are looking for is kind of mainly the open feedback. So, be as critical as you want. We're all in this journey together. And the idea is we are building these platforms and these tools for the customers, for you. So we would want as much of an open conversation and an open feedback as you can.
I mean, what sort of workloads in particular? So if you think about classic, what's of most interest? I guess the pain points that exist in the market right now. So some of the sharing, collaboration, the benefits of cloud native, application development, hosting, scaling.
So some of the problems that we're looking for from our customers to solve are mainly around geospatial data sets and AI. So it's about how we're looking at customers to understand how do they envision the data management aspect to look like in the future. What is the current pain points with data management? What are the biggest and the hardest pain points, especially like I mentioned, like moving gigabytes of data into different places. That's one, and we would like to know more deeper into what is the actual problem there, what is the challenge, and help solve that problem. The other one that is very important for us from the platform, from a partner's point of view, is to understand the UX of the user experience of geospatial, right? Because us coming from a GIS background, we know what we know about how people interact with maps. We know about cartography. We know about how to present data. But what I feel that for the platform, at least, we need to know is how do users actually think about getting insights? When do you actually click at a particular place to get the insight? We can create the insight, we can present it, all right, but the idea is to present that in the right time. I don't want a screen that tells me everything all together at one time. It's about knowing the right piece of information at the right time, right? So if I'm a data management persona, if I'm interested to know, okay, what are all the data sets I have in Canterbury? Okay, now that's a spatial problem, right? Even though I'm a database person, all I want to know is where the data sets are. I need to know where the data sets of Canterbury or of Auckland are. So that's a spatial problem. So that's something that we can help solve geospatially underneath the hood. You don't need to put a map out there, all the end user wants to know is where is my Canterbury data sets, and they just want a list, right? We can do the intercept in the back and find out which data sets are of Canterbury and provide them as a list, but the end output is not a map, right? So, but it's still using geospatial. So that's one of the challenges. In the analytics world, we would want to know, for example, hydrologists and environmental scientists, how they are currently using geospatial, because from our experience, what we have found is they use geospatial, but they use geospatial almost like in isolation, either a pre-processing piece or a post-processing piece after their modeling. So they'll do some pre-processing to extract geospatial data. They'll bring that into their model, their hydrological model, which is not spatial to begin with. And then they would take that and then pass it on to a spatial model of hydrology and then push that through. We would like to understand how can we streamline that more, how can we bring the pre-processing probably and the post-processing and maybe even the spatial modeling part all into their hydrological modeling and how we can help them kind of achieve that. So those are some of the problem spaces we are looking at. Again, on the developer side, usually when people ask for front-end developers, we want to make a map. Their first go-to is either Google Maps because it's just easy. You would like to understand why Google Maps or what are they actually looking for in a particular library or in a particular interface, why they pick certain libraries, why is certain things easier, what do they want, what is missing. So those are the kind of information that we're looking for in the partners, and the initial foundational customers is we want to release the platform to them, understand how they use it, observe how they use it, and hear their feedback to understand in each one of these spaces like data, analytics, application.
I mean, an extension to that would be API integration, right? So, hey, they've already got investments in various tools, BI tools, existing applications, whatever they are.
Yeah.
Cool. Just consume the services, right?
Yeah.
So an understanding of if they could geo-empower other applications, stacks, investments across the business.
Yeah.
Platform's a platform. It doesn't need to be all things to all people.
That's right.
And so how do we just help empower these existing investments? And what are those investments?
Yeah.
So that'd be amazing.
That's the other thing. We want to understand the boundary of the platform as well. Like you said, we don't want to do everything for everyone. The idea is we need to provide the highest value that the end user is looking for at this point, and obviously that is going to keep moving as the product matures. So that's exactly it. It's about identifying what is the highest value items and what are the biggest pain points that users have. I'm not here to replace hydrological modeling, because there's obviously that discipline is pretty mature. They've already got a lot of knowledge and a lot of science has gone behind in how do you do hydrological modeling, or like say groundwater flow modeling or things like that. It's about what aspect of geospatial is missing, or what is difficult for them to incorporate into that model from a geospatial aspect. Yeah. And how can we kind of open that up for them so they can easily consume that?
Yeah. How do we empower those guys so their model, to your point before, doesn't have some spatial attributes, it can become spatially aware.
That's right.
And that's that true empowerment to take geospatial to where it's not.
Yeah, and same thing for the BI guys. I mean, if you already have a lot of BI tools already that you're using, what aspect is missing? Why can't you, for example, have a rich dashboard with spatial information? What part is missing? And how can we just provide that value? We don't want to provide a whole dashboarding capability because you already have a dashboarding tool. Yeah. What is missing from the dashboarding tool, or what is stopping you from providing a richer experience? Then if you can find that out, then we can incorporate that experience into our platform and provide that as a feature for them to use.
And the same thing goes for existing geospatial investments.
Yeah.
It's no different. Hey, we've got these investments over here, actually leveraging this platform, what we're thinking, the analytics pipelines, the reusability, the cloud native aspects. Cool. It's open APIs. Consume it, suck it into your existing investment, empower it, take it to the next level. Don't need to throw the baby out with the bathwater, so to speak, right? Right, so thanks, Santosh, for an awesome deep dive into our thinking and being so open about it. I love your views on what our early customers and partners, what we'd like them to bring to the table, and the sorts of problems and challenges in particular. So look, with that in mind, thank you for your time. Thanks for listening to another podcast of Beyond GIS, and feel free to reach out to either Santosh or I. Thanks very much.